Hello, everyone. My name is Oleg. I am a solution engineer at StarWind company. I hope you hear me well and can see the screen with the webinar's title. Today, we will talk about IT service continuity and disaster recovery in virtualized environment, have a small overview of its approaches, highlight the built-in disaster recovery tools in Microsoft Hyper-V and vSphere, and finally realize if Azure Site Recovery is worth using or not. This webinar targets small and medium business IT infrastructures where buying expensive, overkill enterprise third-party disaster recovery solution is not an option. After presentation, I will show you how hypervisors built-in disaster recovery tools works in action. Certainly, you can write your question in question windows, and I will answer them during the presentation or in the end of webinar. So, welcome to Disaster Recovery 101 Hyper-V and vSphere webinar. Let's start it. Nowadays, the downtime of IT infrastructure can generate huge financial losses or even lead to bankruptcy. I will repeat the old Gartner numbers that 1 minute of downtime costs around $5,000 on average. IT service continuity planning is aimed to avoid long downtime and to recover rapidly after disaster. IT service continuity supports the activities of the business continuity management process and focuses only on those events which are considered by the business to be a disaster. The objectives of IT service continuity management are to provide advice and assistance on issues which are related to continuity and recovery, to maintain a set of plans on IT service continuity and IT recovery which are in support of the overall business continuity plans, to minimize the costs which cannot be eliminated, to make sure that suitable continuity mechanisms are installed which can meet or exceed the agreed upon targets of business continuity. Analyze the impact which the changes have had on the IT service continuity plans, and make sure that proactive measures are implemented wherever it is economical, which will increase the availability of services. IT service continuity operates with two major metrics: recovery point objective and recovery time objective. Recovery point objective is the measure of the maximum acceptable data loss recorded by time, or the maximum allowed age of the data when recovering a system. RPO is measured from the time the first transaction is lost or from the time the hosting services become unavailable. Recovery time objective is the maximum tolerable time allowed to recover system and services after a disaster. The recovery time objective is measured from the time the virtual machines are declared to have become unavailable until such time when virtual machines become available and operational. Recovery time objective depends on which disaster recovery approach is implemented. To protect virtualized infrastructure from disaster or other disruption, the following approaches should be implemented or can be implemented. It is not required to use all of them simultaneously, but properly configured combination of 2 or 3 of them will help to achieve extremely high uptime for application and IT services. We'll start with fault tolerance. Fault tolerance system is one which guarantees zero downtime for virtual machine. It means that both recovery point objective and recovery time objective should be 0, or in case of recovery time objective, it can be near 0 because the system should realize that the second host is down. The protected virtual machine is mirrored in real time between 2 hardware hosts. When a hardware failure occurs in the primary host, the secondary host is running an identical virtual machine simultaneously take over with no loss of service and zero downtime. The benefit of this solution is that then in-memory application state of any program isn't lost in the event of a failure, and access to other application and data is maintained. However, since the redundant systems are operating in synchronized mode with each other, any software problem that causes one to fail will spill over into the mirrored system, making fault-tolerant virtual machine vulnerable to operating system or application errors that could still result in server downtime. By the way, Hyper-V hypervisor doesn't have any fault tolerance for virtual machines. vSphere does, but only in standard and enterprise edition with resource limitation like RAM size and virtual CPU count. Second approach is high availability. It is a light version of fault tolerance. The cluster nodes use resilient shared storage for virtual machines, and if a node will go offline, virtual machines will be started on remaining nodes, certainly if these nodes have enough resources. All in-memory data will be lost, and virtual machines will need some time for booting. The benefit of high availability is that it needs less costs and resources for implementing in compared to fault tolerance. Both Hyper-V and vSphere have built-in high available feature. For vSphere, but at least the Essential Kit Plus license is required. The next approach is VM replication. It is often called disaster recovery or something like that. The basic idea behind replication is that virtual machines, or in some cases individual virtual disks, are replicated from one host or one cluster to another. This allows the hypervisor to create a fully synchronized standby copy of the virtual machine. This virtual server replica usually exists offsite and remains powered off until a disaster requires its activation. At that point, a manual failover process is initiated and the replica virtual machine is brought online. We will cover more regarding virtual machine replication in the next slide. And the last one, I think all you know what is backup, so I will highlight why backups should be implemented if any case, regardless of the fact that fault tolerance, high availability, or replication already exist. Fundamentally, both backup and replication are necessary to keep a source virtual machine's data so you can restore it on demand. However, virtual machine backup and replication have different objectives. Virtual machine backups are intended to store your data for as long as necessary so you can go back in time and restore what was lost, while virtual machine replicas are intended to restore the virtual machines as soon as possible. Hence the differences in the technologies used to proceed with both. Let's imagine that ransomware has encrypted the data on virtual machine and system administrator has noticed this fact after a couple of days. Virtual machine replicas may have some older recovery points, but mostly they are limited by a few days. So you won't be able to recover the encrypted data without backups. Good, let's move to virtual machine replication. As I mentioned, virtual machine replication is often called as disaster recovery because fault tolerance or high availability don't save your infrastructure in the event of catastrophic disaster like a major weather event like hurricane, tornado, etc. as cyber attack, or even in case of confiscation of servers by authorities. Regarding the confiscation, I have a real-world example with one of virtual service provider in my country. One customer used a virtual private server for gambling server or something like that, what is prohibited by law. Police authorities came and confiscated for investigation the hardware cluster where we're running the server of other customers. In such cases, a disaster recovery site can help a lot. VM replication creates exact copies of source virtual machines and puts these copies on the target VMware on Hyper-V hosts. Each time a replication job runs, virtual machine replicas are updated, so they are identical to the source virtual machine. Certainly, their replication frequency should be considered in this case. Recovery point objective time can be selected for each protected virtual machines. Virtual machines replicas are fully functional virtual machines which are stored in a powered-off state, so they do not consume compute resources, only the storage on disaster recovery side. At the same time, if a disaster strikes, all you have to do to restore it is to power on the virtual machines. You can also choose a recovery point, what can be crucial if disaster has been caused by a misconfiguration or software component failure. By default, there are no automatic failover to ensure data consistency, but it is always possible to create event-driven automation script. The recovery time objective time is lower than with backups because virtual machines is always ready to be started. Here you see major vendors who provides replication solution for Hyper-V and vSphere clusters. Among them, Azure, Site Recovery, Wamdu, BDR, Suite, Nakivo Backup and Replication, Altaro VM Backup, and Veeam Backup and Replication. Certainly, it is not a full list. All of these solutions are powerful tools with many features, but require commercial licenses or encryption. In both vSphere and Hyper-V are built-in tools which don't require additional licenses. I'm talking now about vSphere replication, which is included in Essential Plus Kit license, and Hyper-V replication. VMware has also Site Recovery Manager as disaster recovery solution, but it needs an additional license. Before showing it in action, I would also like to mention Azure Site Recovery as a cost-efficient alternative which doesn't require secondary site for DR. Azure Site Recovery is a disaster recovery as a service solution. It enables asynchronous replication with minimum replication frequency 30 seconds of on-premises virtual machines and physical servers to Azure. Data is stored in Azure storage with the resiliency that provides this storage. It's also supported to use Azure Site Recovery as orchestrator for site-to-site replication. So as you see, both VMware Hypervisor and Hyper-V are supported. Also, physical servers are supported. Regarding the costs are moderate if you use Azure Site Recovery to Azure. It costs only $25 in months per VM. Certainly, additional costs for storage should be considered, and in case of a lower compute and network resources. If you are going to replicate from on-premises to on-premises, it will cost only $16 per month. So that's all regarding the presentation. Now I am going to show you the built-in disaster recovery tools in action. Let's start with vSphere replication. vSphere replication should be installed additionally as a virtual appliance. Here you see virtual replication machine, and honestly speaking, the configuration and installation is not very straightforward, and you need to follow the manual or guide. As I mentioned, vSphere replication is included in Essential Plus Kit, and here you see a standard cluster which consists of 3 nodes, or better to say one cluster which consists of 2 nodes and one additional ASXI host on disaster recovery side. All this setup is covered by Essential Plus Kit license. So after the installation of vSphere replication, it should be configured with some additional web. Just a moment. With some additional configuration web interface, and after the configuration, the new option will be in vCenter. Okay, let's go back to vSphere client. So if we would like to replicate a machine, let's take the router VM. We have here an option, configure replication, and actually it opens a new window which looks a little bit strange for me. Okay, something has happened with my browser. Okay, it opened the additional web interface for vSphere replication control machines. So if we are adding a new virtual machine, actually we cannot select a host or site as a target. We can select only a target data store. So you should select it with cautious. And here, as for replication frequency, unfortunately, it can start only with 5 minutes. The other solution has an opportunity to start only with 30 seconds. So in addition, there is an option to create some more recovery points or snapshots and enable network compression if you're using a WAN or VPN, and certainly an encryption. So after that, we will see that a new replica is created and soon it will start synchronizing. So if we would like to restore the virtual machine in case of disaster, with vSphere we have a problem, because we need to have running vCenter. If we are talking about enterprise, about Essential Plus Kit license, which include only one vCenter, then you need a second license for disaster recovery side to have a possibility to recover your machine. So actually, it's a bad point in vSphere, because the competitors like Hyper-V have possibility to restore the virtual machine if the whole cluster will be down. But in some cases, if for example you have a dedicated production cluster in branch office and cluster in headquarters, you can configure this replication between these sites, and in case one site will be completely offline, you will have additional vCenter on the second site. Okay, let's simulate the failure with some machine. Let's take this machine, Apache VM. I don't want to simulate the complete site failure because I will show you Azure site recovery with vSphere, and then we will check how it works if we will lose the whole site. Okay, this virtual machine is down. I can delete it from disk. And here inside recovery, use latest available data. We will restore it in DR cluster. Let's go back to vSphere. Okay. Okay, so virtual machine is running. vSphere replication also has a possibility to have a planned fallback and failover. So not fallback, sorry, there is no fallback. If you need fallback, you should reconfigure the virtual machine on the main site, and it is also one of the disadvantages of vSphere replication. So if you don't want to use vSphere replication, and actually I don't recommend to use it for production, and you don't have budget for such tools like Vim Backup and Replication or vSphere Site Recovery Manager, you can use Azure Site Recovery with vSphere. Azure Site Recovery requires also a virtual appliance, and actually I was a little bit disappointed that a Windows Server appliance is used in this case, and according to the Microsoft requirements, you need to have 1.3 terabytes of available storage for Azure Site Recovery. So, but nevertheless, if we would like replicate something, first of all, we need to configure the Azure Site Recovery appliance. There are a good guide on Microsoft site, and it shouldn't be any problem with it. Then we have here in Enable Replication, we are choosing the source location certainly after adding this. As you see, we have here two sites, one for Hyper-V, one for vSphere. And after that, we will get a list of virtual machines. To replicate virtual machine, VMware tools should be installed, and also in case of using Linux virtual machines, EFI boot is not supported. It should be configured with this. Let's select application 02. So, and also we need to provide Azure Site Recovery with a root access to Linux virtual machine if we would like to add it to the replication. Okay, and the last step, to enable replication. As you see, I have already prepared here one machine from vSphere cluster and one from Hyper-V cluster. So here in machine settings, now we see the health, the diagram, how it is replicated, and under the properties, you can also configure the virtual machine sizing. Here is automatically selected A1 version 2, but if you need more resources for this virtual machine, you can easily configure it for the virtual machine. So now let's make the cluster down, and I will recover the virtual machines into the Azure. Okay, I need a couple of seconds to do it. Okay, now cluster should be down. Azure needs some time to realize that there is a problem with cluster, but in any case, there are no automatic failover. You can start the failover automatically. Here also there is an option to select the recovery point if configured. And now we should wait a couple of minutes to create a new compute resources in Azure. In the meantime, let's go to Hyper-V cluster. Actually, Hyper-V replication is better from my point of view as vSphere replication, because it has additional benefits such as a lower replication frequency starting from 30 seconds, and the failover process doesn't depend on any third-party components or any other components like vCenter in vSphere. Okay, we have here high available cluster which consists of 2 nodes. We have here a couple of virtual machines. If you would like to configure Hyper-V replication in a cluster, first of all, you need to configure a Hyper-V replica broker service inside a failover cluster. And after that, you have a possibility to configure replication. Let's configure it with, for example, web server. Enable replication. We need to specify the disaster recovery server. As disaster recovery server, it can be either standalone Windows server or Windows failover cluster, doesn't matter. So actually the traffic between replica traffic is not encrypted if you don't have PKI infrastructure or Hyper-V or computer certificates. So if you are going to configure replications through unprotected network like internet, so please make sure that you have certificates to ensure the encryption. Okay, as I told, we can select the frequency. Disadvantage of Hyper-V replication is that there are only 3 options of replication frequency. You cannot choose it anyway. There is PowerShell command where you can set the other frequency, but in this case you will get an error that something is not supported. So you are allowed only to use these frequencies for replication. It's also supported additional recovery points, and the data is transferred in compressed state. Okay, so if we go to the webinar, Hyper-V disaster recovery node, then we see that there is here a new virtual machine and the status with receiving changes. Now the initial replication is started, and after that only the changes of initial virtual machines will be transferred. So the replication use snapshots. Sometimes it can be a problem with merging the snapshots, and in this case Hyper-V will start resynchronization, full resynchronization. Let's go back to Azure Site Recovery and let's check. So the failover operation is still in progress, but I think we should have a virtual machine in an active state. No, not yet. Okay, so let's go back to Hyper-V stand. So here we can start a plant failover directly from the console. Have already replicated the Windows server, and it will start the plant failover. Okay, certainly we can start failover only if the virtual machine is turned off. Okay, let's do it such way. Okay. Okay, good. Plant failover. Okay, go to disaster recovery node. Refresh. And we see that virtual machine is starting. Hyper-V replication doesn't have a clear fallback, but you can use reverse replication. It means that you will configure the main cluster as a target for this virtual machine replica, and then you can start the normal failover, and such way you will achieve failback. Okay, go back to Azure Site Recovery. Okay, surely. Starting. So here we have an error because the virtual machine on premises is already inaccessible. That's why there is a problem with shutdown. But here we see that the virtual machine is creating now. Okay, let's go back to Hyper-V. I have a question regarding StarWind for disaster recovery. Okay, StarWind has asynchronous replication for the storage. It is implemented with the called log structure file system, or LSFS. It is replication of the whole storage, and actually we don't recommend to use it for virtual machine disaster recovery. But if you have a file server, then this can be used. We don't recommend it to use it for virtual machines because we also don't have a fallback, and you should copy virtual machines from disaster recovery site manually to the main site in case if you will start your main site again. As additional option, if you have a good redundant connection between main and disaster recovery site, you can implement synchronous replication. For example, let's take 2 nodes cluster on main site and 1 node on the disaster recovery site. With StarWind Virtual SAN, 3-factor replication can be created between these 3 nodes, and stretch cluster implemented. For such deployment, you need at least 1 gigabit Ethernet link dedicated for storage synchronization purposes between main and disaster recovery site, and network latency shouldn't exceed 10 milliseconds. You should also keep in mind that if you have flash drives as underlying storage, the performance of such setup will be limited by 1 gigabit Ethernet. Okay, it was regarding the question StarWind for disaster recovery. Good. So actually take a long time. So I have tested today and a couple of days ago, and so I didn't have such delay with virtual machine creation in Azure. Let's refresh the page. Now it's still creating. Okay. What? Deleting? Okay, let's check what's happened. Okay, good. It's still running. So, if you would like to use Azure Site Recovery with Hyper-V hypervisor, you need to install an agent on each Hyper-V host, Or if you're using System Center or Virtual Machine Manager, you can install such integration package only with Virtual Machine Manager. After that, you will be able to see Hyper-V cluster under the sources. I have already shown you that source location. We see here this Hyper-V cluster, and here we will see the virtual machine. So should also here select the storage count, and now we see virtual machines without replication to Azure. Let's take App Server CentOS for replication. Here we should indicate the OS type, and replication frequency is configured by replication policy. You cannot configure it for dedicated virtual machine, only for the whole policy, but for different virtual machines you can apply different policies. So enable replication. Okay. Good. This completing failover. Okay, start the failover has been successfully done, and now we see a virtual machine from our vSphere cluster up and running here. As for replication from Hyper-V to Azure, you can fail back the virtual machine after the disaster, and also with Azure Site Recovery you can also do a migration from on-site to Azure if you are going to migrate a part of all your infrastructure to Azure. So here is our cluster, and if we check now this virtual machine, let's refresh. We should wait a couple of seconds because Azure Site Recovery is still configuring replication for this virtual machine. Let's check the status. Okay, in progress. But we can check already replicated to Azure machine. Under the replication health, we see here the replica server Microsoft Azure and a statistic. So if we would like to restore, the process is the same as with vSphere protected machine. If you have, for example, hundreds of virtual machine, you don't need to click on each machine and replicate it manually. You can configure a recovery plan and include in this recovery plan all virtual machines that will be automatically started or in Azure if this plan will be triggered. So here we have only one virtual machine, but we can add as many as you want. Okay, So, see other question. What about using snapshots and then recovering VMs? Do you mean StarWind snapshots or snapshots in hypervisors? Because StarWind snapshots, as I already mentioned, are storage snapshot. You should mount the snapshot first of all, and after that it will be mounted as a separate StarWind image disk, and only after that you can run the virtual machine from snapshot. Yes, you can do it, but if you would like to merge the changes with your main infrastructure, after recovering it, you will not be able to do it with the StarWind. So you need manually copy VHD, VHDX, VMDK, and so on to the main site. If you are talking about snapshots in hypervisors like vSphere snapshots, snapshots are saved on the same data store on the same site as the virtual machine. Snapshots can help you in case of some misconfiguration or software failure. You can revert the changes and so on. But if your site will be completely down, snapshots will not help you. Backups will help you, but you need to prepare infrastructure to configure hypervisor, and only after that recover from backups into newly prepared infrastructure. Okay, clarification. Yes, regarding StarWind snapshot. I also would like to add some additional points about log structure file system which support snapshots. This file system is officially supported only on hard disk drives as underlying storage. It is the first point. The second point is log structure file system requires additional RAM resources. It's 4.6 gigabyte additional RAM per 1 terabyte of storage. And the last but not the least, LSFS need up to 200% over provision. Yes, it supports deduplication, but still, if you would like to provide, for example, 10 terabytes for as disaster recovery storage with snapshots, then you should have up to 30 terabytes on the underlying storage. This file system was designed and deployed more to eliminate I/O blender and to convert random reads operation and random writes operation into asequential writes. So it can increase the performance of your underlying storage, but it takes the additional capacity and RAM resources. As I mentioned, for virtual machine replication and disaster recovery, we recommend honestly our customers to use other solution and not StarWind. StarWind works excellent with high availability. So you can configure easily hyper-converged, high available cluster with only 2 nodes and with a very good performance. So, but if we're talking about the asynchronous replication, so there are solutions which looks better, honestly speaking. So mostly we advise our customers to take a look at Vim backup and replication as solution for disaster recovery. So another question, if there is a phone number, can call into audio. No, there is no phone number, and no audio is supported. Okay, so let's check here if the virtual machine from Hyper-V cluster has been already replicated. No, we have some problems. Let's check. Issues with connectivity. Okay. Resume application. So here, okay. Now it's good. So I think it makes no sense to wait until the replication down. So that's all I would like. What I would like to show you today. If you have any additional question now, so please. Okay, yeah. Another question. Can Azure site recovery be used with VMware Essential license, not Plus? And how to best calculate cost of service and disaster recovery? Azure site recovery can be used with Essential license, but you will not get the local high availability, and actually any problem with one node will lead that the virtual machines in this node will goes down. So how to the best calculate cost of the service and DR? Okay, if you're going to use Azure as disaster recovery site, it will cost $24 monthly per one virtual machine. In addition, you will need to pay for storage. So you should calculate all storage which is occupied by your actual virtual machines in your cluster. So, and then depending on type of Azure storage, SSD, HDDs, and so on, you can calculate the cost for storage. For example, if you have 1 terabytes of these drives assigned to your virtual machines in your cluster, then you need to calculate additional 1 terabyte for storage in Azure monthly. But you don't need to calculate compute and network resources, because this cost appears only if you fail over virtual machines to Azure. Thank you for attending. I wish you to have a nice day, nice evening, nice morning, and a good weekend. So, goodbye.